In the relentless march of technological innovation, few breakthroughs capture the imagination quite like a robot that mimics the death-defying acrobatics of a fruit fly. On December 3, 2025, MIT engineers unveiled their latest feat, a sub-gram aerial microrobot, weighing less than a paperclip and roughly the size of an old microcassette. This marvel doesn't just fly, it dances through the air, powered by soft artificial muscles that drive its oversized flapping wings at blistering frequencies. It executes aggressive aerial stunts with precision, performing 10 consecutive somersaults in just 11 seconds and sharp turns enduring 160 centimeters per second wind gusts. Saccade-like pitches propel it forward like a living bullet, all while staying within a mere 5 centimeters of its intended path. Compared to its predecessors, it flies 447% faster and accelerates 255% more aggressively, thanks to an AI-driven controller infused with a neural network modeled on fruit fly neurology. This isn't science fiction, it's the culmination of years of bio-inspired engineering at MIT's Microsystems Technology Laboratories. The robot's secret lies in its two-pronged control system, a high-level planner anticipating uncertainties, paired with a low-level executor optimizing thrust and torque. No longer confined to timid hovers, these bots can weave through cluttered environments, recover from mid-air tumbles, and sustain flights up to 1,000 seconds. As lead researcher Jonathan Howe notes, the robust training method is the secret sauce, blending simulated data with real-world tweaks. But what elevates this from a lab curiosity to a paradigm shift? Its scalability. At 750 milligrams, with a lift-to-weight ratio of 2.2 and speeds topping 100 centimeters per second vertically, it's engineered for endurance and agility. Future iterations promise onboard batteries and sensors for untethered autonomy, unlocking deployments in realms where bulkier drones falter. As we stand on the cusp of 2026, this micro-robot isn't just pushing the boundaries of robotics, it's poised to infiltrate industries desperate for nimble, resilient eyes in the sky. First, in search and rescue, disaster zones are the ultimate proving ground for agility, where seconds count and environments turn hostile. This micro-robot's insectile grace, flipping through narrow gaps and stabilizing against 160 centimeters per second winds, makes it ideal for urban collapse scenarios. Imagine swarms of these bots infiltrating earthquake-stricken buildings, scanning for heat signatures or audio cues from survivors. With 1,000-second hover times and centimeter-level trajectory accuracy, they could map unstable structures in real time, relaying data to human teams. Next, in agriculture, bees are vanishing, and with them, a third of global food production. This robot's high-frequency wing flaps and acrobatic control could simulate bee flight to dust pollen with pinpoint accuracy. Its endurance means covering vast orchards, all while dodging rain or wind, and deploying fleets for hyper-localized pest detection. Farmers could slash chemical use by 50% or more, boosting yields in precision agriculture. Third, for environmental monitoring, ecosystems demand unobtrusive observers. This micro-robot's featherweight design and silent flaps minimize disturbance to wildlife, allowing it to hover undetected. Its aggressive maneuvers shine in dynamic terrains, somersaulting over mangrove tangles or stabilizing in coastal gales to measure ocean acidification proxies. For conservationists, this means granular insights without the carbon footprint of manned flights. Fourth, in infrastructure inspection, bridges, wind turbines, and power lines age in silence, their hidden flaws exposed only by catastrophe. This bot's sub-centimeter precision and wind-resistant flips let it thread needle-like through turbine blades or under bridge girders. Equipped with hyperspectral cameras, it could detect microcracks, corrosion, or thermal anomalies in real time, logging data for predictive maintenance. Finally, for military and defense, in an age of asymmetric warfare, size matters and smaller is stealthier. This micro-robot's fruit fly mimicry offers unparalleled covert ops. infiltrating enemy compounds through ventilation shafts, performing 360-degree flips to evade countermeasures. Its neural net brain enables autonomous pathing in GPS-denied zones, dodging small arms fire or electronic jamming while streaming encrypted feeds. As MIT's Microrobot takes its first untethered flights, the question isn't if it'll disrupt, but how profoundly. These aren't just machines, they're echoes of evolution, refined for human ingenuity. In disaster's shadow, fields of gold, wild frontiers, creaking infrastructures, and shadowed battlefields, they promise efficiency, safety, and insight at scales once deemed impossible. Yet challenges loom: scaling production, ensuring ethical AI governance, and hardening against hacks. Still, in a world teeming with macro problems, this micro marvel reminds us that the boldest solutions often start with the smallest wings. The insects have been acing it for eons, now it's our turn to catch up. To watch more such videos on new technology and analysis affecting our future, please subscribe to channel China Tech Chamatkar.